Hi, I hope you're doing great. So let's discuss the code file that you sent me. Initially, we just need to load the files, load the packages that we need for the analysis. We load our dataset. Since it's an Excel file, that's why we use read Excel function. Okay. Now the algorithm that we're going to use is k-mean clustering, and k-mean clustering don't work whenever we have columns with characters like this, and this one. So basically it only works with numeric data. So we should be considerate about the columns that we need. Now to do so, what we need to do is we need to subset the columns, and we can subset it by using data.frame command. By using that particular command, we need to specify the columns that we need, and we're going to specify price, square feet, beds and baths. Now once we run it, and if we see the code file, if we see the data variables, we can just double click it, and we can see that we have variables like house data, price, house data, square feet. So we need to rename the columns, and we will rename it by using the function names. Names basically is related to the names of the data set. So in the names function, we will write name of the data that we want to modify the names, and here we are going to say that the first column is going to be price, second square feet, third beds, and fourth baths. Now once we've done that, we need to check the structure of the data. That's quite an important step, because the k-mean clustering only works on numeric data, and if our data set has some kind of problems, like in that particular case our square feet, beds and baths columns are character type instead of numbers, so we need to work on them and we need to modify them. What basically we need to do is we will use the function as numeric. Basically convert the other columns into numbers, and we will convert these three into numbers. They already have the numeric data, but the only problem is R is unable to understand them as numbers. So by using as numeric, we will able to modify them. The logic is basically quite simple. We are going to say the data frame, from data frame SQ square feet is equal to the numeric form of that particular column. So once after doing that, when we check, now we do have the same data, and we have numeric type instead of character type. So now our data set. Now before jumping into k-mean clustering, we should understand that how k-mean clustering works. To understand how k-mean clustering works, we basically need to create a plot, and let's make a plot to understand. Okay, so basically we are going to use k-mean clustering, and we have variables like price, square feet, range, beds and baths. Now beds and baths are kind of correlated columns. Like if we have more bedrooms, we are going to see more baths. So that's why it's better to visualize the relationship between them based on price and square feet. Okay, now this is the data that we are going to implement k-mean clustering. Now first of all, we need to understand what a cluster is. Okay, clusters are basically when we have data points that are at some distance from each other, and basically k-mean clustering is a distance based algorithm where each point we calculate the distance of each point, and based on that distances we create the clusters. Now let's start with k-mean clustering. Okay, and let me copy this image and open it in a Paint so I can explain it a bit better. Now that is our plot for price and square feet, and we want to implement k-mean clustering on this. So whenever we are going to use k-mean clustering, what we need to provide that how many centers there are going to be. Like in our case, we will check the function, check the coefficient. We will check different methods to identify the number of clusters, like elbow method and other method. Now the algorithm tells us that there are going to be 2 clusters. So what it basically going to do, it will create 2 different points. It will select 2 random points from the data set. Like for the moment, and I say that this point is considered as first random center and this point is considered as second random center. So at first step, it will calculate the distance of all the points from that particular point and from that particular point. All the points where we have less distance to this point will be assigned to that cluster, and all the points where we have less distance to this point will be assigned to second cluster. So at the first we will get something like this. There will become one cluster like this, and the second cluster will be like this. This point will also be included in either this or this center, this cluster. Now this was the first step. After that, the same process will repeat again. Now instead of taking 2 random points, we will select a point which is closer to all the points. Okay, like for the moment we are going to say that this point is much more closer to all these points, and on average it's closer to most of the points. So this is going to be our second center. Okay, in the same manner this process will repeat in this thing and this cluster, and we will get a new center. Now again we will ignore the clusters because clusters are not set till now. Okay, we are at center 2, the center 1 is this one and center 2 is this one. We will ignore these one now, and we will again calculate all the points distance from this point and this point, and based on that we will create two new clusters. Okay, and they are going to be something like this. Sorry for my bad drawing. And now we will repeat the same process, and we will be able to identify the third centers. Let's say it goes somewhere there, and this one comes to somewhere there. So in the same manner basically, or we will keep creating new centers, we will keep creating new clusters until and unless we get the final set. Like we are not going to get a new center. Like we select the point and we check the distance, it is closer to all the points in the cluster already, so it's not going to be different point. So once we reach to that particular step, it means k-mean clustering converged. K-mean clustering converged basically means that yes, we got our results and we got our two different clusters. Now for the sake of clusters, we need to understand something. Clusters are basically data points separated from each other. Like now these data points, or we can say these data points are one cluster, and for example these data points should be the second cluster. The cluster should be separate from each other. It doesn't mean that there should be the free points, but they should be separated from each other. Or we can say this cluster has these points and this cluster has these points. Okay, now the problem is, what we can see from our data is there are no two clusters. To be honest, there is only one cluster, this one, and all these points are basically nothing but outliers in our data set. Now this is actually an outlier instead of a cluster or something like that. Okay, so that is basically the main issue. Now it doesn't matter if you are not getting a higher coefficient or not, because your data set is not supported for k-mean clustering. Now instead of that, if our data something looks like something this, for example, we have a lot of points here and we do have a lot of points here. Like in that particular case, we have a lot of points. Okay, now they are well separated from each other, and by just looking at them we can distinguish between them that this is something else and this is something else, right? But by looking at this, we can clearly see that this is just a one cluster and there are some outliers. They are not two clusters basically. Okay. So now let's move on to our code. Now choose method basically tells us, so mbclust method basically helps us to identify the optimum number of clusters. If we run that, we will see that we have two clusters optimum. Okay, and when we use two clusters and we get something like this. Now the cluster 1 has 3046 points, but cluster 2 has only 214 points. Do you understand why there is such a wider gap? Because these 200 points are basically the outliers from that particular data. Okay, or not all, but from 200, half of them are going to be just outliers. Okay, so now let's switch the mode. Like I just want to say I'm going to see the optimum number from elbow method, and I run it again and I plot it. It will take some time. Now by the elbow method we can see that the optimum number of clusters are basically 4. Like from here to here we see significant decline. This is a significant decline. This is a significant decline, but after that we will get a straight line, almost straight line. So optimum number of clusters from here should be 4. Why we are getting 4 here in this method and 2 on other method? The problem is our data set is not problematic. We don't have support for the data set. Okay, now for the moment, if I go there to the plot and I say we should normalize the columns, and then we will get better results. Normalization will not, or scaling will not help us, not going to help us. Why? Because by scaling we are just going to change these labels. These bigger number will be replaced with some tiny numbers like 5, 10, 15, 20. In the same manner, these will be replaced with the tiny one, but the actual shape of the data, it will remain the same. Okay, that's why the problem is not with your model. Problem is with the data set. Now let's move on to the k-mean clustering and let's plot the results. Now if we plot the results, this is cluster 1 with lot of points and this is cluster 2 with basically 214 points. Now for the data looking like this, it is a good separate. Okay, like it's a good clustering. Like the points are not mixed up with each other. We have the one cluster underneath and above the second cluster. But the problem is they are just outliers. Okay, they are not different clusters. So that's why our methods are only showing very less number in second cluster. Now here I started to normalize the things. Before normalization we have cohort width of 0.78 and after normalization it reduces to 0.68. Okay, so instead of getting better results we are going to get worse results, and there is a logic behind it. because if we are going to decrease these numbers, we are basically making these points little bit more closer to each other, and they are basically going to mix up, and with the mix up we are going to get less coefficient score. So that was the k-mean clustering. Now let's talk about hierarchical clustering. Now the problem with this is, even if you were able to create the plot, it will not worth it. It will not be, you will not be able to explain it. Okay, you know why? Because you have a data set with 3000 rows. Okay, now even if you are able to create a dendrogram, the problem is there will be such a mess that you cannot even see it. And also this is basically a lazy model, and there are not much of there is nothing much that you can do about it. Okay, now for example, instead of that, this is a little bit more computationally expensive function. I go with hclust and I plot the dendrogram. Now this is what I get. Now what is the point from what we can talk about it? Like, if you think that this is not about the plot and our code is wrong, instead of that, what we can do is we can just take the first 30 lines of the code, 30 rows of the code, and run the line again. Now you can see that the code is super fine, code is working perfectly fine. We are creating two clusters. First cluster have 13 rows, second cluster have 17 rows, and from here we can count 13 and 17. 13 here and 17 here. But the problem is, when this cluster have 3000 numbers in it, it's going to be messed. They are going to overlap each other. You cannot realize it. You cannot even see it. Okay, so that's why it is totally fine to, if you don't have anything like that. So that's it. If you have any question, feel free to let me know, and have a good day.